Hi, this is Jackie Kluxen, and this is my Advanced Learning Ops screencast about objects in freefall. So, first thing that we need to know about objects in freefall is what exactly freefall is. So, freefall recurs to a falling object in which the only force acting on it is gravity. So basically, this means that there's no air resistance or any other forces acting on the object that is said to be in freefall. So basically, it's just the object is falling and gravity is pulling it down. There's nothing else attached to it, no resistance, nothing like that, just gravity. So let's start off with an example to base this lesson around. So here it is. Two metal balls of differing masses are dropped from the same height at the same exact time. There's no air resistance or other forces acting on the two balls except for gravity. Which ball will travel faster and hit the ground first? The heavier one or the lighter one? Or will they hit the ground at the same time? So this is a really popular question for physics about two objects of differing masses being dropped, and we're about to find out what the answer is. So the answer is that the two balls will hit the ground at the same exact time. They also fall at the same rate with the same acceleration. Now, you're probably wondering how this will happen. So, how is that possible? It's actually very simple. Acceleration is the same for any object in freefall, no matter its size, shape, or mass, as long as it is, in fact, in freefall. So, how are we going to figure this out? How do we know that acceleration is the same? Well, we need to find out what that acceleration is so we can prove that it's the same for any object. So, what is acceleration? The first thing that we need to do is draw a force diagram. I have one drawn right here, and it's just the ball is a circle, and then the arrow coming down from it represents the force of gravity. Force of gravity equals the gravitational field strength, which is 9.8 for Earth, little g, times the mass, which we don't know, which wasn't given for this problem, we don't know it, but it's okay because we don't end up needing it to solve for acceleration. So we have the force of gravity equal to 9.8 m, with the m representing the mass of the object. So now we can look at the equation for acceleration, which is acceleration equals unbalanced force over mass. So our unbalanced force is the force of gravity itself, 9.8 m, because it's the only force acting on the object. So that goes on the top of our equation, and then we have m on the bottom, which we don't know, so we're going to leave it as m. So our equation we have now is 9.8 m divided by m. So what you notice by this is that it ends up being 9.8 m over m, so the m's can cancel out, the masses cancel out. So you're left with acceleration equals 9.8 meters per second, which is the units for acceleration. So our final result is that any object in freefall has an acceleration 9.8 meters per second downward, and the reason it's downward is that it's the only way an object could physically fall on Earth. Still don't believe it? Let's use our problem from before with actual values for the masses and solve for acceleration to see if they would indeed hit the ground at the same time. So we're going to say that ball 1 has a mass of 2 kilograms and ball 2 has a mass of 4 kilograms. So I drew up some force diagrams for each one. So for ball 1, we have the force of gravity equals 9.8 m, because that's what force of gravity is. And then force of gravity equals 9.8 times 2, which is the mass of ball 1, which is given to us in the problem. So we have force of gravity equals 9.6, and that is the only force acting on this object because it is in free fall. Then for ball 2, we have force of gravity equals 9.8 m again. So force of gravity equals 9.8 times 4, since that's the mass in kilograms of the object. And then when you multiply that out, you get the force of gravity equals 39.2 newtons. So those are our two force diagrams for this problem. So if we go back up to our screen, we know that ball 1 has a force of gravity of 19.6. So when we can go back to our equation, acceleration equals unbalanced force, sigma f, over m, mass. So when we plug our values in, acceleration equals 9.6 over 2, and then we get, what do you know, acceleration equals 9.8 meters per second, just as we predicted when we were solving for acceleration. And it's the same for ball 2. Acceleration equals 9.8 meters per second because when we plug our values in, we get 39.2 over 4, which divides out to 9.8 meters per second. So, as you said before, as you can tell from this, the objects have the same acceleration, they're being dropped from the same height, so they're going to hit the ground at the same exact time. So if we go back to our slide before, we can conclude that the acceleration of any object in free fall is 9.8 meters per second downward. And that's it. Hope you learned about about objects in free fall from this screencast. Thank you for watching.